Hey guys, welcome back. Let's go over the animation system in Unreal. Now this will be a fairly long video in and of itself, so I do recommend you kind of stock up on snacks and all the human things that you consume. That being said, let's go over our current predicament, which is how do we make this this collision a little bit more precise. Because if I go to play right now, and you will see that my ball is bumping up and down, and there's all these bumps, and this isn't good, okay? This is not good because this will impair the ability of skillful play, okay? We want skillful, high skill ceiling gameplay. And for that, we need to eliminate the possibility of a rogue collision, in which case, as you can see, this does not really conform very well to our original object. That being said, we need to somehow generate a new one. So if I double click my skeleton asset, and we're going to start from the beginning so that you have a really good understanding. What is that pose doing here? This was just a thing. I'm going to delete this curve because I just wanted to create a pose to see something for testing purposes. We actually need to create a pose anyway. So we'll do that later down the line so that you know what a pose is and how it works. Okay, first of all, the skeleton itself. What is the skeleton? Is that the same skeleton? Here's the question. Do you think that's the same exact skeleton that you saw in Maya? If you said that this is the same skeleton, then you're wrong. It is the same hierarchy, as you can see here, has the same names, but this is not the same thing as a skeleton. This is simply a reference table for a skeleton or a joint hierarchy. For that reason, we will kind of separate the two, okay? The stuff that we made in Maya is the joint hierarchy. This is the skeleton. The reason for that is this allows you to interchange animations between things that have the same names and the same amount of joints, or even a different amount of joints. But as long as they share the same naming structure, you could share animations between the two. Now, how does this exactly work? Well, it's not like you can share animations between like two completely alien skeletons, all right? Two a completely alien joint hierarchies. But you can share something. Let's say we had a snake and this worm, and we wanted to attribute to the snake this the worm jumping animation, which we created. This will require us to either recreate the jumping animation for the snake itself, or we could simply retarget this. Either retarget this skeleton for the snake skeleton, or simply make the snake skeleton with the same joint naming convention, allowing us to automatically assign the same animations to it as well. As in, whenever you import the stuff, you will basically add it to the same skeleton. So this wouldn't be only a skeleton for the worm, but for all sort of ground-crawling creatures that we will have in our game. And we'll have a lot more joints, right? It could have more than this structure, right? It can have a head joint and a tail joint and all that, and they will simply not be used by our worm. The important bit is that stuff that has more joints than, like if, in our case, let's say we had a snake which had more joints, retargeting animations from the thing that has more joints onto the thing that has less joints is easier than retargeting animations from the thing that has less joints onto the thing that has more joints. It's definitely possible, and the procedure is pretty much the same, but like the results are not as good, okay? The point is that you can have the same skeleton drive several different entities depending on the amount of joints that they have. For example, one character might have 3 arms, whereas others might have 2, but you don't want to recreate all the animations for the guy with the 3 arms, so you could just use the 2-arm animations and then compound that with a 3rd arm, which you animated separately, and just imported animations for that. Now, that being said, it's important to understand that this is much like a label, all right, or a container, okay? I'm going to use an analogy because I do think they really kind of break the point through to people. Imagine if you had a bottle of Coca-Cola and a bottle of Pepsi. Now, both of these things are similar yet different. Or let's say a bottle of Fanta or Sprite or whatever, right? They're both liquids, sure, but they're both in bottles. They have different names, they have different tastes, different colors, different all sorts of stuff, but you can very easily take one liquid and transfer the liquid between them. So you could have the Fanta and the Coke, and the Coke and the Fanta bottle. But because it's the same type of bottle, it's basically half a liter plastic bottle, it allows you to easily transfer liquids and stuff between them. Now take the same situation, we have a Coca-Cola bottle, and then a jar of pickles. Now, yeah, it's possible to grab the liquid from the jar, and just, shove it into the bottle and then just start smacking pickles in it, and maybe fit, maybe it won't. Of course, from the bottle onto the jar, it will be very simple, right? You just simply pour it into the jar, but not vice versa. This creates a little bit of a one-way street when it comes to these kind of retargets, because yeah, you will get your pickles in the Coca bottle, but how effective are you going to be is questionable. And thirdly, imagine the same Coca-Cola bottle and a steak, right? I mean, those two things literally have nothing in common. Except for the plastic in them. Ha, joking. Imagine like a really good steak, not one of the garbage things that they sell in the stores. Like a freshly killed deer or something. I don't know. The point is that you cannot force the steak down the actual Coca-Cola bottle effectively and try to eat it from there, right? You're not going to be able to drink it. So these are two completely different things. This is what the skeleton is. It's a container for a bunch of stuff that have relations between each other, but are not too alien between one another. So you do well to understand that. Now, what else do we have here? Well, of course, we have the details panel, which allows us to, whenever you select something, you can grab and move the transform around and select change the bone name, I believe. All these reference scales, these, as far as I know, have to do some with the retargeting. I'm not sure. And then you got the animation notifies and the animation curves. Now, these two things we're not going to go over just yet because, as you can see, we don't really have any animations at all. So there's that. You got, by the way, some settings here such as retarget manager, which is what you use whenever you have other joint hierarchies which do not conform to your naming convention. So currently it's r_joint, but if I had joint_r, you would need to actually retarget these to tell the engine which joint, which name is the same on the other side. So you'd have to retarget r_joint2 to joint2_r on the other skeleton if you wanted to actually interchange animations between them. Basically them becoming available. You can also create a static mesh, and this is something that I think it's kind of a gimmick, but a lot of people you might find useful. So you just create some deformation, such as maybe this, right? And there's your horns or something. I don't know, this looks really bad, but basically you create a static animation from that, and this allows you to make a statue, or even have a pose that you can swap out for the main character. Like, for example, you could think of it as, imagine if your character is frozen or petrified, and like you want the guy who got petrified to turn into like a destructible mesh. So you need to convert the pose that he was petrified into a static mesh, because you need to swap the static mesh for a destructible mesh, meaning that once he's petrified, someone can break him to pieces. So that's how this would work, right? So that's why you have the static mesh bit. It's not the most useful thing, but it definitely is useful for stuff like special effects, right? Being frozen, being all that. Obviously, you can drive that through other means, but that's one of the ways you could do that. Because again, destructible meshes, as far as I'm aware, cannot be animated. Now, after that, we've got the mesh tab. Now, these three tabs, by the way, will expand in a little bit, but I want to go through them so that you kind of know where we're coming from. First of all, we have the material slots, which allows you to, assign materials, which currently is assigned the m_worm, which I created in Painter. Then we've got the LODs. Again, the level of detail is automatically created for you the further away you are from the camera. There's loads of different settings for LODs and how they get generated. So 100 units from the camera, things start to blur. It has to do with bitmap generation, and they use the Simplegon algorithm to reduce the faces without actually like dealing too much damage to the final shape of the object. That being said, as far as I'm aware, in the next version of the engine, they will scrap that or upgrade it or replace it with something which is supposedly better. I'm not sure. But as far as I'm concerned, I don't have to do any LODs. That will be generated automatically. I simply do not bother with this stuff over here, right? I don't care about LODs. I don't import them. As you can see, you can import them over here, but that you got to be really like hardcore, or you got to be making like a mobile game. If like, it's a rare occasion, I think, these days for people to be making LODs because they generate it automatically, and they do a really good job with that. That being said, you can definitely work with your materials and set them to, you know, have less channels, for example, on them, or turn to grayscale for worst case scenario. But in general, when it comes to LODs, I simply do not bother. They're automatically generated for you depending on the distance from the camera. Then you've got the clothing, which we will touch upon for something else, not this, but for something else. And you've got the mesh itself, the skeleton setup here, and different bounds and UV settings. The physics asset, which we will talk about in a little bit, and you've got the shadow physics asset, which I really have no idea what this is. I think this has something to do with the way shadows and lighting is calculated. Yeah, so this is basically if you want to simplify the load of your light calculations. So this is kind of like like you want to reduce the cost of processing power. Then you've got your post-processing animation blueprint, which is for like what you want to actually utilize for that. You got the import settings, assuming you have imported this. Like if you want to change the import settings for this, you want to re-import this, you can just modify these as well. You've got your animation, which we do not have, and the thumbnail, of course, how it's going to be generated, etc., etc. That being said, really this is not what we need, because we need to talk about physics. I forgot to talk about this side. Yeah, so as you can see on this side, you've got the morph target preview, which has to do with blend spaces, or blend modes, or blend targets, or however you want to call it. It's the same thing as the blend deformer in Maya, and you create a smile and a frown and a bunch of other deformations, and you simply import them as morph targets, so to speak, and you got all these weights. So it's pretty much the same system as in Maya, so not much to be said about it here. And again, this is not really a facially expressive object, so I doubt we're going to be using that. Then you've got the animation mode here, which currently is the default, but you could specify a reference pose, a specific animation, which we currently don't have, so that, you know, that's what it is. Then you've got the additional meshes, which is kind of like if you want to add a bunch of stuff to it. So like, I don't know, like trinkets, doodads, whatever you add to it, you can actually add a bunch of skeletal meshes to this skeletal mesh. So it's you can compound stuff, like the third arm, for example, would be an additional mesh, right? So there's that. Then you got the settings, such as for example, the profile name would be so the profile, as far as I'm aware, is responsible for all of these things here, including these, I believe. I'm not sure. I haven't actually created separate profiles for the same object, so I don't really know. But as far as I'm aware, this is basically your settings for how this gets illuminated, how things get, how things work, basically, right? You got your color grading, the lens, the rendering. Like, this is like, if you're going to be making cinematics or something, right? That's what you'd be doing. You got even a tone mapper here, which I didn't even know existed. Jesus Christ. So that's pretty sweet, I suppose, if you're into cinematics or some such. But judging by the fact that you're watching this video, you're most likely not at that level. So we could skip this for now. I'm simply going to collapse this. Now we go to physics. Now the physics is the important bit here. I will simply show the... Where's my constraints? I need to show the limits. Now, if you remember, when we created the object, we had our Y positions reversed because we wanted symmetrical movement. So if I add a movement, if I add rotation to this here and the Y in the positive direction, the Y here will be the negative direction. So if I select both of these and I just add a particular amount of degrees, this will rotate inwards and this will rotate inwards because it is the opposite of this side. That's why we see this difference. Of course, I could also have created them to made them to kind of like look the other way, but then I would have had a much more difficult sort of situation. Okay. Now, this is not ideal. Again, we don't really want this. We don't really want this situation here where these are by the way, these are the constraints. So these are the degrees of freedom for our object whenever it's ragdoll. This is essentially the ragdoll, by the way, so you could also think of it as your, oh Jesus Christ, that is a very small object. Instead of just talking, let me just show you this, all right? If we go into my constraints and just remove them, and I simulate, you will see that our object is deforming and it's fallen and is struggling to survive at this stage, so it's a dead worm. Now, of course, you could really, modify this to have a much better deformation and, talk about different constraints, how much something could rotate, because currently I don't think this is a really good result. But that's something that we could use later down the line if we really wanted to. Okay. Now this is of course not ideal. So how do we create extra objects, collision for this object? Now if I select this capsule, for example, you will see that I have my graph here, and I can, I can grab something off and assign other joints to it. But for now, we'll simply keep it very simple. In the physics department, we've got some things such as enable gravity. You could disable gravity on a per object basis. Basically have a bunch of settings for each capsule here. So that's pretty good, I suppose. Then you got your different body setup, what kind of primitives you want to be using. And like currently we have a bunch of capsules, 4 members, right? And these 4 members are 0 through 4, right? So all of these have their own kind of setup. And you also have a physics animation, which has its own profile. You can actually take a look at them here. The physics animation basically says that you can have a profile for ragdolling a part of the object, not just the whole object. So if this was kind of some kind of an explosion, you could think of it, well, hey, I want to take these ends of the worm and ragdoll them so it just flaps around while it flies in the air, but I don't want it to be deforming all the way. Or I want this to happen as the animations are playing out. So I want to affect only these external capsules, these ending links, so to speak. So what you can do is create a profile and say, well, we want to assign and unassigned bones to it, and this profile will be part of the things that you'll be using. Same thing goes for the constraint profiles. You can create one profile and assign different constraints for each profile itself. Fairly self-explanatory, I believe. There's not much philosophy going on here. And then you guys, you can see the physical animation. You can assign profiles here, or they will be automatically assigned if you already have done so. Ooh, that's a lot of talking. And then we've got the preview scene settings, which allows you to simply set up again the same situations that we have the meshes, right? So it's the same setup here, so you don't really have to swap between tabs. Now we need to create a different sort of collision system. Let's see what we can do. If you remember in the static mesh creation, you could create all sorts of different collision types, but here we only have 5. Let's try the box. Let's see what happens if we use the box. I believe the minimum bone size is essentially, well, like it's not the actual size as in Maya where you have the radius of the bone. It is the physical distance between the two objects. So if there's something that is shorter than 20, it basically would be disregarded as a collision worthy. So you set this distance yourself, and the higher it is, of course, the less collisions you're going to get per your object, right? That being said, we should go ahead and create this box. So I'm going to say create the joints, blah, 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 generate all bodies. Well, this does not really look that good. If I simulate, it just falls. So there's really not much. I'm going to check this guy out, by the way, because it's currently checked in. So there's not much of a result here. Well, we have another option we could try with spheres, right? So let's go for a sphere, and I'm going to generate the bodies. As you can see, my spheres are a little bit more massive on one side than the other. So that's because, of course, the weights themselves, so the way the weights work, and I simulate. And yeah, like this doesn't look very good either, especially with spheres. It's looked much better with capsules. You can also create a convex hull. Now the convex hull, the single convex hull will create one for the entire mesh. The multi-convex hull will create one for each bone, as far as I'm aware. I think if even the tooltip says that. No, it doesn't say it. Unfortunately, it doesn't say it, but that's as far as I'm aware, that's how it is. Now, the multi-convex hull will take ages to generate one. Not exactly ages, but compared to the actual other collision settings, it's definitely quite a lot. So I'm going to use the single convex hull, and I will simply generate these bodies like so. Okay, as you can see, we have a much better representation of our, collision system here. Now, this has a downside, of course. If we simulate, this is not really gonna be doing much because it kind of like, it's pretty much the same mesh, just in terms of collision. It's very expensive, sure, it is expensive, but in our case, we really we can afford it. All right, we have only 2 actors in the actual game, so we can afford that. That being said, let's see how this performs. So our new collision has been set up. As you can see here, we have it available in the game. If I play, maybe I should just ignore this for a second, because this is for testing purposes. I believe we should, oh come on, check everything out. We should simply move this object a little bit closer to the camera, like so, maybe a little bit further down, so that we see much better what's going on. Okay, and if I play, as you can see, my ball is pretty much, I'm gonna just restart, my ball is pretty much very smooth. Like the surface of my worm is very smooth all the way down to the edges. By the way, there is some of a little bit of an issue here, as you can see, with the actual collision. As you can see, when I move it, there is something catching it on this side, like this bit here. This is catching it, I think. I'm not sure. If I do this way faster, it will bump. There is a bump somewhere on each of these sides, but it shouldn't really be that much of a problem, since we won't be we will not be creating this situation where the player can balance the ball on top of it. All right, so just make sure that this is just a test for the collision itself, and it does perform admirably. That being said, we need to figure out what we're going to do with the animations now. So I need to create another folder. I'm going to call this animations, and I need to import my animations. Before we do that, though, we need to see how exactly could we generate a pose. As far as I'm aware, unfortunately, here we cannot, so I need to create one. First and foremost, the pose itself, just so that you know what this is. Now, that's the bit that I believe is going to be changing from, like, the next, either from 4.19 or 4.20. I'm not sure when, but this particular system will have a change. So this might not be relevant at all, or might be somewhat relevant. They probably won't like do away with it at all, so you will still be able to use poses, but my guess is they will build up upon it, so they won't scrap it completely. If we take a look at the pose asset, we can simply create one from the bone skeleton. I'm call this idle, and the idle pose right now is well, it's empty. There really isn't much going on for it. What we need to do, of course, is create a pose. Well, yeah, a pose, and that's going to happen by creating a animation from the current pose, and we'll call this, well, we will call this idle. Really, this is the idle animation, so idle. Now let's click OK. Okay. No, I don't want to replace it. I need to call this something else. Let's create this as a, we can create a pose asset. Let's create an animation as the current pose. I'm just going to say idle animation. Maybe I should have made this idle pose first. So in the animations bit, we simply click OK, and that's our animation. Of course, currently there isn't really much else, but I need to stop this and maybe add some frames. So I'm going to append at the end, just I don't know, 3 frames, like just so that we have a frame or two, right? This isn't the most ideal thing, but it's fine. Again, this is not going to be animated at all, so this really isn't something that is concerned for us. But as you can see, we now have an animation, and that's really nice. But we do have anything else? No, we don't. Before we import others, we need to talk about this editor here a little bit. And in fact, in order to do that, I think I will simply delete this idle bit. There's nothing is using it. And I'm going to leave this as an idle. And I'm going to create a animation blueprint as well, and a blend space. So we'll do quite a lot of work here. The animation blueprint itself, we'll talk about it a little bit further into this video, but for now, I'm just going to call this player 1 animation VP. Now that's kind of that. This is what's going to be holding the logic down. And then we've got, I want to create a blend space 1D. Should I do this now or let's do this later. So I'm going to do this later once we import. Now, first of all, in the animation blueprint, what is it and how does it work? As you can see, the tabs over here have started to increase. We first have the blueprint itself, then we have the animation, and we have the mesh. So there's quite a lot of things to go over again. So let's just do that right now. And for more dramatic and obvious results, I will actually import our next set of animations. As you can see, we've got the jump and the walk. These are our originals. For some reason, Visual Studio has overtaken the default association with the files, but that's fine. I can just do this manually by Maya. Now, whenever you import an animation, you have to tell it, well, when do you want to, which assets or which skeleton do you want to assign this to? And currently, of course, it will be this only one, because we don't have one. We only have one skeleton. If we didn't have one, we'd have to create one, which is, by the way, done automatically, so you don't have to create skeletons on your own. Now, the animation length over here, if you take a look, we're currently using the exported time, and that's a boon of the modular animation approach that we've taken. So we've only exported the animations with the skeleton and not the mesh. So each FBX is its own standard animation. We don't have to define a range. Otherwise, we might have to set a range and start defining different ranges here from, let's say my jump is from 0 to 60, and then my walk is from 60 to 300, and then et cetera, et cetera. So you need to keep like a record of where your animations are at. But exported time is usually ideal for whenever you have properly set up FBX files. It's good to know how to use the import range for people, like if you buy an asset or somebody sends you an asset, or you inadvertently create an asset with a bunch of keyframes, like 600 or 600 frames, or even more. You could have like 6,000 frames. I don't know. The point is that the more frames you have, the more difficult it is to import. So this is where your preparation and your export discipline will it will be a benefit to you. Okay. You've got a bunch of other things such as curve suffixes if you have some different materials, which we don't. And of course, if you have any morph targets, those will be imported as well. We currently don't have any, and you can also obviously replace them if you want. But without any morph targets or anything such as that, well, this is pretty much the default settings that we need. I'm going to import all, and we're going to get an error which says mesh geometry has no name, and the FBX file is not referenced by any hierarchy node. And this essentially means that we don't have any geometry in the FBX, and that's fine because we only use the animation here. So I basically tried to import the animation here as well, the mesh as well, I believe. Is that what happened? Let me try this again. Yeah, so I import, yes, I imported the meshes. So if you disable this, this should, alleviate the issue. Let me just prove my point to you by deleting this stuff and redoing the import. So there we go. We're going to import this again, select these two, and I'm going to remove the import meshes and bone hierarchy because we don't have any. Assign a skeleton, import all. Okay, maybe it will still tell me that. Maybe I forgot another tick somewhere. But this is not an issue, right? This basically means that you don't have a mesh in your animation, in your FBX, which is fine because we don't want one. That was the whole idea. Now, in the idling bit, as you can see, we have nothing. But now we've got two more. So let's take a look. We've got the walk. Well, the walk. Okay, maybe not the best rendition of walking, especially with this bouncing up and down. But, hey, it'll get the job done, right? It's not the best, but it'll get the job done. And then you've got the jump. So this boomerang shape is what we'll be using whenever we're rotating. So it's important to kind of understand that currently we'll be driving gameplay through the animation. So this is not a very high quality jump, but it's something, right? So in the future, you might want to modify that, replace the FBX, and re-import it. Re-importing is very simple. You simply go over here and you say to asset actions. No, I think you can actually reload them and it'll be fine, but re-import with new source or simply re-import on its own. So there's really really loads of ways to modify the asset. So once it's in the engine, do not worry to modify the original import file. Okay, let's go back into our animation setup. First of all, on the left side, we've got the skeleton tree, which is pretty much the same as the skeleton here. This allows you to just take a look at your skeleton without jumping between tabs. And then you got the asset details, which is identical to the mesh setup here. Well, almost. In the physics menu, why did I lose that bit? Let me just close all this and reopen it in one proper situation. So in my content here, I'm simply going to open my skeleton, and here I should have everything. Okay, excellent. Excellent. There we go. We got the blueprint and the physics. So the whole thing is open, and we can actually browse between the tabs. So in the animation settings here, you've got your animation setup. So if you're using a particular pose, you could preview the pose here. You can use a retarget source if you've set the retarget sources, like I've already said. What kinds of interpolation you want between keyframes. It could be step or linear. Linear is much better. The rate scale is how fast the animation is playing, and I do believe it's possible to play it backwards. If I simply make this a -1, if I actually click on it. Yeah, it is playing backwards, as you can see. So that's fine. That's how you see it, by the way, because, you know, obviously playing it backwards wouldn't make much sense, especially in this situation. So we have this and this. So it's all looped, okay? So kind of like playing it backwards is not going to give us any good results. Then you've got the skeleton, which is the skeleton asset we're using. The parent asset, if we have anything that is being this is inheriting from something. And then you got the asset mapping table, which I have zero clue what it does, by the way. And then you got the user data, which I also never used. The additive animation type, that is, if you have other animations that you want to add on top of this, like for example with the guy with the third arm or something, you could use the mesh or local spaces, and you can add them as additive layer tracks whenever you assign them to your profile. Different compression, bitwise compressions here. Like I never bother with this, but if you want to lower the size of your game, you do want to use this most likely. Then you got the root motion, which is responsible for, well, root motion. Remember, that's why we set this up over here. The root itself, where is it? The root itself over here, that's what's going to be moving. So if we move this, like if we move kind of like the object forward, so this will basically move the root as well. This will allow the game to know that the whole character is moving. And I already talked about this before, so you should know what root motion is, right? This is just one. If you set this up properly, just enabling root motion will be just fine. And of course, you got the reference pose of first frame or 0 or whatever it is you want to be using. Then you got the same import settings, just like you did with the skeletal mesh, well, the mesh part of the skeletal mesh. You've got the miscellaneous. I'm not sure what half of these things do anyway, because I never bother changing them after import. Yeah, like the convert scene. This is the basics, the same things that you have in the FBX importer. So this is kind of like re-importing on the fly if you really want to. Next, you've got the notifies, which are really handy things when it comes to operating your game logic, because a lot of stuff can work out of these notifies. Now, generally, imagine that for a second you wanted to fire off an explosion every time the character is, let's use the jump here as an example. Every time the player is at the apex of the jump, right? Somewhere like here. Every time the character is at the apex of the jump, you want to be firing off an explosion, right? Maybe somewhere here. Now, how are you going to find frame 11, you know, in order to fire this? How are you going to time this? You need to time this, right? So you don't know how long it's going to take for the animation to fire off. And, you know, it'll be a lot of trial and error. You'll waste a lot of time. But there's definitely a way to do this. You can simply right-click here and add notify, and you can play either a particle effect or play a sound. You can have a montage notify, assuming it was a montage, which I'll talk about in a bit. Or you can create an entirely new notify, which is a custom event. Then you also have notify state, which I'm not sure what the difference was. I kind of forgot, but just go ahead and read through the documentation. There's definitely a lot of them. And in the manage notifies, of course, you can take a look at all the notifies that you have. You can create extra tracks here if you really want to have like different types of notifiers. For example, this would be for explosions, this would be for sounds, and etc., etc. Because again, you want it to be on the same frame, for example. but I'm going to delete this since we don't need it. The curves themselves are very similar as well. You simply add a curve from a variable, and you know, it basically controls how the animation is played. All right, so there's that. And that's pretty much it. Yeah, you've got the additive layer tracks, which should be here once you have your animations done. And this is the slot manager, which is part of the profile setup as far as I'm aware. So yeah, everything is here at your fingertips. Now, of course, you have also the preview scene setup, which is your mesh settings, essentially. As you can see, the mesh settings are the same. So the animation, the mesh is the same. And the details, of course, are for whatever bones you decide to select. Note that you cannot actually modify these as far as I'm aware. So if I go ahead and just decide to make this like that for frame 15, I don't think this will actually change. Oh, it will. Okay, well, that's pretty cool. Huh, I didn't know you could actually do that. I'm not sure if this is persistent. I don't think this is persistent. Like, even if I save this, I'm pretty sure this would break a bunch of stuff. Generally speaking, don't try to move the bones. But if it works, it works. Give it a shot. I don't know. I mean, I never actually had to do that. But this seems pretty sweet that you could... Ha! Okay. Well, obviously, it'll be very difficult to make this to work with the rest of the keyframes because you can't really keyframe and interpolate between them. This is basically permanently changing the starter pose of the object. But it's pretty sweet. It looks pretty cool. Okay. That being said, we're done with the animation bit here. Now, one more thing to talk about when it comes to the asset browser, by the way, is the blend spaces. So if we take a look at the animation folder here and create another, we need to create a blend space. Now, we're going to use the blend space 1D. And by the way, this is where you create also an animation montage and an animation composite. I'm not sure what a composite does, but you can always just check the documentation on your own. Chances are you don't have enough animations to be warranting a composite or really a montage. But like, imagine if my backflip was actually animation, a specific animation, so you use the montage. This is how you would fire things like reloading and well, basically a bunch of one-off things, right, that cannot be part of the state machine, which we will talk about just in a bit when it comes to states. But I want to finish with the possible animations. I've got loads of different assets here, such as aim offset and aim offset 1D. This is for third-person shooters where you want the like where do you want the weapon to be aimed at, and then you've got the level sequences, which is kind of like cinematics. The paper flip book, which is for 2D stuff. You've got a sprite sheet. The pose asset, which you already saw, just creates poses, snapshots of poses, and can create stuff from that. And the blend spaces. Now, the blend spaces have two options. You've got the regular blend space, which we will create. And you've got the one-dimensional blend space, which we will also create. Now, how does this work? Well, very simple. You have your sort of track here, which starts from 0 to 100. You can rename it to whatever you want. Currently, it's called none. But in the name here, I could say that, let's imagine for a second, this is my axis input. Okay, so this is my left and right input, and it could go from -1 to 1. Right, and this is my input, left, right. And whenever I'm in a particular position, I want to be using that. So let's say if I'm going left, I want to use my walk. If I'm going right, I want to use my jump. And if I'm standing in the middle, I want to use my idle. As I drag my mouse here by holding down Shift, you will see that I'm slowly going into that animation, assuming, of course, I play the damn thing. So as you can see, I'm currently not moving. Currently at 0. There is a little bit of perturbation, but that's because I'm not perfectly zeroed out. And as I move forward, you will see that I'm going into my final movement here, and the same goes for jumping. Now, of course, this is not how you would do this because this is very dumb, right? You wouldn't be using a blend space for that, but because I'm lacking, we're lacking in movement types, we don't really have to, such as going forwards or backwards, right? This is for stuff that is one-dimensional, okay? Now, when it comes to the two-dimensional blend spaces, things a little bit more different because here you actually have two axes. So not only you got the X, but you also have the Y, and they both represent different things. So here you could have the axis input, and here you could have the rotation, or the opposite. This could be an input, this could be the rotation. It's basically a 2D graph, right? And the cool thing is you can actually add blend spaces. No, you can't. But blend spaces are considered animations, so you could use them as animations. But like I said before, you simply have a value from whatever it is you've set here to whatever it is you've set there. You got the idle bit, for example, when everything is 0, you'll be standing in the middle, which is very simple. Then you've got the jump, which is, imagine here that this is some kind of maybe an automatic height, maybe a backflip, right? So if it's, you could drive this through the height of the character, how high the character is. If he's very high, he can do a backflip, and this would be a backflip animation. Otherwise, if it's not above a particular threshold, this could be just a regular jump. And then, of course, you could have something like a walk here, depending on the speed. So you could really do a lot of really interesting blends here using the blend spaces. So it's important to not master, but really understand how to use them, because they will save you a lot of animating. So there's that. Okay. By the way, you can also just hold down and drag this stuff along. Notice, by the way, that whenever I'm not in this immediate vicinity, so when I'm under these, this is the quadrant that I'm in right now, there's really nothing that gets affected. But then the moment I go up, I'm starting to go into the sort of this situation. This is simply an idle spot, and this is a walking spot. So yeah, it's pretty sweet. It's pretty interesting how this whole thing performs. That being said, we don't really have a use for these blend spaces, but I'm going to leave them here just to demonstrate something for you. We go into the animation blueprint next. Now here's the meat and bones and potatoes and pretty much everything else when it comes to the animation setup. How does it work, what it is, and how do we utilize it? First of all, you have to understand that the entire library for the animation blueprint is different from the library of the event graph. It has its own event graph, and it also has its own event tick, which is the event blueprint update animation, basically a tick. Now, this blueprint has its own variables, has its own functions, has its own logic, and it's basically a separate event graph. It doesn't have the same things. Like you cannot, for example, create a timeline, such as here. If I just timeline, there is none. I can't create a timeline because this is an animation blueprint. That's not how it works. However, obviously, it's possible in the event graph. A lot of the things are possible here. You can use a branch. You could use like a flip flop, I believe, or do n. Flip flop was it F? No, it's a for each loop. I kind of forgot the shortcut for flip flop, but you could use these, and then you can call an animation montage. So, for example, as you can see, this is the montage bit. Again, we're not going to go over the montage, but this is how you use it, and you can reference different things. Actually, sorry, not here. You could reference that in the state machine. But here you've got the event graph, and this is kind of like your logic side of things, right? You basically set different variables, parameters, grab a bunch of logic from the target components, and work with them in a particular way. This will make a lot more sense once we dive into the animation graph, which is the more important, technically speaking, side of things. Again, notice you have event dispatchers, variables, macros, all sorts of stuff. All your notifies will be fired off up here, I think, so you're really not going to have much of an issue with figuring out how this works, because again, this is the same thing as the event graph and the in the main bit. Now, the animation graph itself is a little bit different from what you would expect in general, because it's working with results, right? It's working with the pose result. It doesn't have an execution pin like the event graph over here. This is an execution pin, and this is a pose. Now, you could still use a branch here, but you can't actually hook up any results here. Now, branches, I'm not sure you can still get executable things off of here. You can't get an update though. You can't get a begin play. A bunch of things. For example, an event, right, that's fired off of a notification, you could use that here, and it would do something, and you would actually create maybe a blend. I think you can create a blend space. No, you can't. Well, there's something. I think there is some way you could use this. Yeah, you can spawn actors. Like, there's loads of different things you can do when it comes to actor spawning. But you kind of limit it when it comes to that, because in general, you'll be using these execution pins in your event graph. And I do think the fact that they allow you to create these statements here is kind of redundant, because this logic should be reserved for the event graph. You don't want to have any execution pins running around here. That being said, you need something to drive the final pose, because currently we really don't have a pose, right? The result is, as you can see the note here, the result was visible but ignored because, again, there's nothing to be feeding in. And even if you right-click, Control-Alt here, you will see that your animation has nothing to process because it's an empty graph. Now what we're going to do is create a state machine. Okay, now from here to state machine. Add a new state machine. Now, what the hell is a state machine, you might ask? Well, it's an interesting topic. It could be a very complex topic, but we'll talk about this in a very basic way. And as long as you understand the basics of it, you can really dig into it. What's important to understand is you can have as many state machines as you want. So I'm just going to call this movement, right? Because we only have one. And as you can see, this state machine outputs. What does it output? Well, it outputs a result. So if we compile, this should be happy. Great, we got a result, but the entry node is not connected to a state. There's really nothing feeding this animation just yet. So we need to change that, right? Obviously. You also have a bunch of settings here, such as how many transitions per frame, I believe this is. And then you could skip the first update, which is definitely what you should do. And there's not a lot of settings here that are important. You don't have any settings on this one, but when we double click here, we suddenly have a entry node, and this does have an execution pin. Well, what do you know? So what do we do with that? If we right click here, you only have three possible things to add. The one a comment, one a conduit, and one a state. It's important that a conduit cannot actually be the first thing that you hit after an entry, all right? Whenever you go into an entry, if I just compile this, it's going to tell me error. You can't actually have a conduit. And a conduit is much like this, right? It's a sequence. So it just goes from 1 till 2 till 3. It doesn't even work that well inside the state machine because you don't want that to be in the state machine, right? And as far as I know, you can't even hook these together. So this conduit is essentially the same thing. You can grab states off of it and you can just branch off, all right? But in general, you don't want a conduit as your entry. So the entry must connect to a state, which is the default state, which is the regular state. This is a resting or just idle, all right? This is your idle state. Almost always this is going to turn into an idle state. The idle state needs to have an animation assigned to it. Now, if we go out into the animation graph for just a moment and I grab a particular animation, let's say I grab a walk and I assign this. I can't, like this. And I assign this and I compile. This will be walking all the time. Okay. Currently it's playing backwards though, because I believe in my walk cycle I've set this to play backwards. Did I? Yes, well that was my mistake, my bad. So save this like that, and there's my thing. Of course, if I wanted to play backwards, I simply need to duplicate this, and I probably will have to do a jump and duplicate the jump and play it backwards just so that I can get a landing, because I don't have a landing animation as well. But for now, we'll just use it like that. Now this is not what we want. We could modify this, right? We could grab, let's say, a idle, right? And I could blend between them. So I could just type in blend, and let's see how many options we got. We can apply an additive blend. We got loads of different blends. You can see we blend different poses in terms of units, etc. These are all the numerators. I never used all of them, of course, because it's just ridiculous. This is based on whatever, so it's got a numerator value. So there's loads of different ways to blend stuff, but the more obvious one would be to simply use a blend. You can blend by int, by bool. Like these are the most often things you'll be using, but then there's of course the enumerator blends. Here you've got the A, and then you've got the B, and you've got the alpha itself, which could be driven through the event graph. The alpha is essentially a variable, so you can promote it and you can work with it like that. So if I just give this a result and compile, currently, of course, you'll have this bit, but I could also be blending it at 0.5. And now, if I preview this, as you can see, both of these are feeding together. So this is much like a blend space, really. It's the same as a blend space. All right, it's identical to a blend space. You can drag this off, and you can. I don't think this blend space has anything in it just yet. Yeah, so this is the 2D blend space. And this is the axis input. So if we had an axis input, we could even get it here, I believe. Get input, just maybe left, right. Get left, right. No, can we do this in here? Well, we need to get the player pawn. Now this is very dangerous, by the way. You don't want to be doing this in the actual animation graph. These are unsafe operations, and the engine will warn you of that, because if you make a mistake and it just doesn't cast, as you can see, there's no execution pins. You can't actually fire off an execution here. This could be very dangerous. All right, so this pawn, for example, could cast to, let's say, player 1 worm, and it can't. You can't cast. It's gonna you do a pure cast, and it could fail. But from here, for example, you could grab something, or you could grab controller, for example. Okay, just get player controller, and here we could grab the left right. Left, just input. Okay, get input. Okay, axis. Jesus Christ. Okay, for some reason I can't actually get it, but I should be able to get it. Let me just see here. Axis, left, right. Okay, maybe I can't. I thought I could. I really thought I could. But in any case, you don't want to be doing this here. You want to be doing this in the event graph. This is where the logic is being fed. This is where the logic has been defined, and it's being fed over here in the animation setup. So I'm going to delete these for now, since we want to use our state machine for the logical bit. In the movement, I have an idle situation, and it needs a result. The idle bit, of course, will be my idle animation, and we'll simply play that. Just compile that so that everything stops. So my idle animation here is going to be playing all the time, as long as I'm in the idle state currently, right? So we enter and we go idling immediately. Now we need another state, which is for walking. Generally speaking, you could have a walking to idle blend space, which is probably something that we need to do. In fact, I think it's imperative that we do that. Although we could definitely use the actual, we could definitely use the, you know, like the states here. But for now, we're going to define only a jump state, since I want my idle to be using a blend space instead of simply this pose. So right now, I will define a jump. Oh, Jesus Christ, a state. And this state will be jump, right? Now, of course, after we jump, we need to be able to land. So I need to duplicate this and call this land. And of course, from jumping, we have to go to land. After we jump and land, we have to go back to idle. So it's a very simple machine. And it should make sense, right? If we're not, once we're idling, we can only do one thing. We can jump. After we jump, we can only do one thing, and that is land. Of course, there is another situation where you still got the double jump, so there's that. But we'll be controlling this through the logical conclusion if the character is grounded or not. So all of these things have conditions. As you can see, we've got these little conditions here. And by the way, you could go both ways. You can go from landing into jumping, into idle, into whatever, and you can share these conditions between them. So is grounded is generally a shared condition, because if something is grounded, then it's not in the air, and you do whatever it is you want to do, or the opposite. That being said, this is all we're going to do right now in the state machine, because currently there is really nothing to do, except that in the jump, I want to be using the jump here. For some reason, it doesn't let me do this. Let me just try this. Okay, I don't know why that happens, but it allows you to do it. It's just that it's not very happy to do it for you. And then in the landing bit, we really don't have anything just yet, so I need to duplicate the jump, call this land, open it up, play this at -1. Okay, so there it is. The jump and the land, very simple. Save this object, and back in the, where's my blueprint here? In the land, I'm simply going to use the land like so. Again, we could drive this in a blend space, through height, for example. If something is higher than it should be or lower than it should be, you could drive that as well. But I'm going to use this for now. It's a very simple setup. Okay, that's how state machines work. Let's take a look at the event graph and really figure this out. In fact, in the idle bit, since I wanted to use that as a blend space, let's go ahead and really define our blend space. Now, I'm going to delete the actual blend space, because we don't need a two-dimensional one. And I'll use the one-dimensional blend space. I'm going to call this idle to idle walk, just idle walk. All right. Here we've got something very simple. We have, well, actually, I think I might have even done it, except we're using a jump, and it's not what we want. We want to walk on both sides. So both sides, whether it's -1 or 1, we will be walking. So that's very nice and simple. The axis input is already defined. We really don't need to do much else. Average interpolation, that's just fine. Nobody's really going to care or notice us changing the directions. And again, this is going to be more prominent when you use a joystick, since the actual analog stick can provide more than just 0 to 1, whereas the keyboard is pretty much 0 to 1. It's interpolated, but like you can't actually half-ass it in the middle. It's very difficult to hold a 0.5 input axis with the keyboard. I don't even know if it's possible. So in that aspect, the joystick is superior. But that's pretty much it. That's the only thing the joystick is superior in. Now, we have our idle walk situation here. Now we need to assign this to our animation state. So I'm going to delete the idle, and I'm going to use the idle walk. And now I need an axis input. Well, I don't have an axis input, right? That's right. We can just promote this to a variable. I'm going to call this axis. And we only have one axis, so it doesn't matter what kind of axis it is. It's just simply left, right. Probably I should name this P1 axis, but since we will most likely inherit from this blueprint, we'll be just fine. Now, in the event graph itself, we need to kind of set this axis somehow. So that's let's do just that. First of all, we need to grab the. I think there is a begin play here, isn't it? Oh no, what am I doing? Begin play. Yes. So over here we can cache some references. We need to grab the player controller. Okay, we actually need to get up through here. Player controller, which is controller 0, and we simply need to get input left. Okay, left, right. Okay, where the hell? How did I name the damn thing? 1 second, guys. Okay, it's not here. My bad. Where's my controller? It's in the game logic. Of course it is. What is that bit? Get P1 left, right. Okay. That should be it then. Where is it? Okay. We have to cast this first as well. It'd be a good idea to cast the thing. Another thing to do well is to promote this to a variable and call this worm controller ref. And it's going to be part of the refs. It's just a good habit, I think, to have these things, cached. It takes more memory, but it doesn't have to be done every frame. Although you could definitely do that. But as far as you're concerned, it's almost always best to do the casting before. You don't want to be casting very often because it can compound to be quite expensive. Now you've got the axis bit. You need to set the axis, but the axis itself here is going to be changing all the time. So you need to get the axis on its own. So here's my axis, and I'm going to set this to whatever value it is. I don't know what value it is just yet, so I'm going to get the worm controller reference, and I'm going to grab my P1 left, right. Where's my P1? Okay, are you for real? Why can I get the axis just left? Input? Can I not get an input? Okay. Velocity. Yeah, we could get the velocity. That's for sure. I don't know if this will work. The velocity, I don't know if it will work. It gives out a vector. We'll be using the x and we'll be basically using the x-axis, I believe, is it? No, we're using the y-axis. So let's see if this is going to work. I'm not sure if it's going to work, but it's worth a shot. So there's my y value. The velocity should be actually normalized. Normalize axis. Oh, that's a rotator. No. Well, I think that should still work, I believe. Is it? Yeah. Okay. Boom. Because this might be, I don't know if this is normalized or not. This gives you like centimeters per second. That's not what you want. That's your normalized, and you simply set this as the axis. Again, I'm not sure if this will work correctly, since this will give it. Oh, this is an angle. Jesus Christ. Okay, normalize to range. Minimum -1 and maximum is 1. So I might have to do it this way. I knew it was a rotator. Probably wouldn't have worked, but hey. Okay, so we are setting up our axis, and now in the idle state, this axis will be driving our idle walk, and then of course in the movement bit here, we've got the landing. Now we need to figure out if the object itself has landed. So let's take a look what my kind of logic is here. Do I get the grounded bit? No, there is no grounded bit. So the grounded I have to get from my worm, as far as I'm aware. Let's take a look. Do we have a grounded here? We don't have anything that gives us the ground, but we do have this bit. So let's use the onComponent hitbox and say that, you know, just create a variable here. Terrain. Yeah, we could use that. So let's create a variable. It's going to be is grounded. It will be a bool. By default, it'll be, oh, I don't know. It should be yes, I think. So by default, it's grounded. So in the terrain, here we will say, okay, we want to, I don't know, after the gravity, for example, set the is grounded to true, because the character is grounded. Otherwise, in the update, or otherwise it won't be. It won't be grounded. So whenever he jumps off, we need to set the end of the thing to not being grounded. I think this will work just fine. Not the most elegant solution. There's definitely way better ways of doing this. I'm just not sure if I should do this in the update. Let me just see the tick. It's going to run all the time. But then once you set this, yeah, well, I might have to create a function for this and call an event just to toggle the thing. But let's just keep it simple for now and simply set the grounded bit here to no. It's not grounded. It's negative. And just for safe measure, let's use the double jump as well and say, yeah, even if in the double jump, we are not grounded. I'm not sure if this will break it though, because it depends how, like, when you can double jump. But this is kind of an extra redundancy for what we've got right now. So compile this, and we have a is grounded situation. We need to make this, of course, public, so we can modify this through our animation blueprint. Notice, by the way, that I could have also promoted the axis here and simply gotten the axis from the player. I'm not sure why I can't get the left right. Let me just see here, left right. It doesn't let me do it. That is very strange. Input. There's no way to get input here. You have to get it from the actual player, which is very annoying. But yeah, imagine that. Yeah. Oh well. There really isn't much. There's no way to get the axis value, so you might have to get it like in terms of maybe a speed or whatever. Because the speed, this would return you the speed. This is just the normalized value in the range. So that's, I'm not sure how that. Like I said, I'm not sure if this is going to work exactly as I envision it. But hey, it's part of game development. You always make mistakes and fuck ups. Now, in the idle bit, we have this set up. The jump is set. The landing is set. Now we only need the conditions themselves. So the jumping bit is, of course, here we can enter the transition. Here we need to figure out when can we go into the jump. The way we can do this is, of course, if we go into our event graph and actually get the player character. So in the caching bit, so we need to get owning. Well, actually, we need to try get pawn owner, which is going to be the owner of the setup, and we need to see if is grounded. Is grounded. Actually, I need to cast this to a P1 worm over here, and as P1 worm, well, I don't know. Do we really need to we don't need to set this as a reference, do we? All right, let's just let's grab it as the memory and put it in memory commit. So it's going to be play one worm ref. Going to be part of the references, like so. Come on, ref like so. And then as that, we should basically get is grounded, get the is grounded, and promote this to our variable, which should be is grounded. Now, the reason we're not using the is grounded bit directly is because it's just not safe. All right, if you try to use something that does not exist, it might create problems. So I'm simply creating my own is grounded variable. So currently, this is how we're going to be feeding it in, and we need to figure out if we are grounded. So in our idle to jump, we need to set a condition where if he is grounded, we will not be jumping. However, if he's not grounded, so it's going to be true, right? This is going to be true whenever the guy is on the ground, right? So we need the opposite of that, right? The opposite of that is going to be when he's in the air, and we need it to be enabling transition at that point. Again, think of it this way, right? Can enable transition. If this is true, we can go into jump. But however, do you really want to jump when you're grounded? No. So we need the opposite. So we simply need the opposite, and that's going to be not Boolean. If the character is not grounded, then we can go into jump, right? And if you go outside to the movement and just click here, you will see here that the transition rule is that the character is not grounded, right? And so whenever grounded is true, right, this will return false. Whenever grounded is false, this will return true. And when this is true, we can go into jump. I hope this makes sense. And you've got the blend logic if you want to do a standard blend or a custom blend, like you can create a blend graph. But we're just going to use a standard blend for this. And you can also create this to promote this to a shared sort of condition. So this is good because we can use this somewhere else. So I'm just going to promote this. It doesn't really matter though, because we only have one other state, which is the landing bit. So we don't really need that, actually. Now the jumping is going to be performing itself, such as the actual play jump here. And then we need to create another rule for landing. Now, if we play the landing here, I believe it's possible to preview this in... No, it isn't. Okay, I kind of thought this was possible to preview in the actual editor, but this is how our jump is going to perform. We might have to actually speed this up to -2, actually. So I'm going to call this maybe 1.5. Maybe -2. Oh, -1.8. Again, this is of course arbitrary. The blend is going to be smooth enough, especially at landing whenever the player lands, but it's good to actually have it finish, right? So over here in my player character worm, where did it go? Where did it go? Oh, there it is. Here in my landing animation, I need to set this to be whenever the player is grounded, I want to be landing. And if is grounded is true, which is the player actually gets grounded, and we can only do this, right? We can only do this after jumping. So the player will be grounded, but as long as he doesn't get airborne, you won't be going into jump. And if you don't go into jump, you can't go to land. So you shouldn't worry about landing when you're grounded, when you haven't jumped. So that's how state machines work. Once you've landed, this is of course should be, we should go to idle whenever we have the land animation almost complete. Is that correct? Yes, of course it is. And I should rename this into idle walk, right? Here my condition should be how much time is left of the previous animation, right? I need to know how far land is, right? The landing animation is, and currently I have no events here, by the way, which are my, by the way, like notifications. But let's see how much time this is going to take. By the way, you can also have custom blend curves over here if you really want to. Again, it's not necessary, but you can definitely do that. This is the blend settings themselves, right? The current duration, by the way, is 0.2 seconds. This is how long it takes to interpolate between the jump and the land, and then between the land to the idle. Default settings are fine here, but you could definitely change the mode. There's loads of modes, right? Loads of modes. Or you could create your own curve, but this is highly unlikely because this covers about 90% of the, your needs when it comes to, to curves. These are basically types of curves: the cubic, the linear, the Hermite cubic. I don't know what the difference is between Hermite cubic. Oh, there is. Oh, there! Look at this. They actually show you the thing. How cool is that? Let's see. Sinusoidal. Yeah, it just doesn't work very well. There we go. You've got different ones, circular in, out. There's some really cool ones. Instead of defining one, they're really well done. Exponentials, in, out. So it's good stuff. You definitely get your choice. And as you can see, I really don't see. There isn't really much difference between Hermite. Well, this is a little bit more. Hermite is a little bit more linear. Cubic is a little bit more eased in. Anyway, that being said, you can also have your blend profile, which supposedly you would have set this up earlier. Remember the profiles that we were talking about before. And then you got the events. But anyway, I kind of forgot to talk about these whenever we talked into rules because I forgot that you guys wouldn't be very interested in that. And bidirectional, of course, allows you to go both ways. As far as I know, this is not supported just yet. If I compile, it should tell me, no, it's working. Interesting. Though for some reason, I'm not sure why the rule, there's only one rule for bidirect. I'm not sure how this is going to work. Because generally speaking, you could go like that. This will mean that you have a separate rule. So I'm not entirely sure how bidirectional works. Maybe there is some other rule. What if I just click this? Let me just see. Let's just experiment here. Connect to transition. Okay, so that doesn't, it basically governs one situation. That's all right. Now here we need to grab the time remaining of the land. Now because we don't know how long it's going to take to land, since, well, we're going to change this, right? It's minus 1.8 as of now, but it could be different. You could get the anim ratio, which is how much percentage is left. Now there's another bit where it's, I'm not sure what the relevant thing is. Oh, for the most relevant, I don't know. I don't know what this is. No idea. But the idea is that this should be, let's say this should be less than float. Oh, it's over here. My bad. It should be less than, well, when it's almost done. So 0.1. Okay. Whenever this is almost done, we'll fire this off and go into our idle state. If I compile, this should work out just fine. If I just leave, we should have a very basic state machine running, which has some very basic rules. So in this case, the rule is if it's less than 0.1, the amount of time remaining to run this, then you've got this, which is basically, it's going to fire whenever the player gets grounded. This will fire off whenever the player is not grounded, and this will be firing off all the times on its own. So let's take a look at what we've got in the actual animation graph. We have to hook this guy in and compile. And there we have it. Now, again, you could have another state machine. So state machine, and you could be blending between these two state machines, in any particular situation, driving the alpha through. There's loads of different ways. You can really go as granular as you want. You don't have to have the idle walk in one way. You could have the walk separately, the jump, the land. Obviously, the more you break it down, the more complicated it's going to get. Eventually, you might end up with a huge graph with conduits left and right. So you want to balance the blend situation, the blend spaces with the state machine. Because think of it this way: whenever you have something that will be, whenever you have a value that will be driving an object, an animation, then you use a blend space. Whenever you have a state, such as a Boolean, that will have to drive an animation, then you have a state machine. Or a state. And whenever you have something in between, which is just doesn't fill any of these categories, you make an animation montage. That's the way I see it anyway. It's the most easiest way of, sorting out what it is you need to use. And try to keep it symmetrical, because symmetry is key. Like this. I think this is symmetrical. Anyway, compile, and I don't know, let's play. Let's see what happens. Let's see if our velocity is going to work, and it does not work. Unfortunately, it does not work. So let's take a look at what happens then. This is how debugging works, by the way. So you simply click play, and then you click in the event graph. Okay, for some reason this does not actually give me the opportunity to why can I not see my game instance? That is really weird now. Right, let's see the axis then. It's currently 0.5. Well, that's a problem. That is a problem because it's not being updated real time. Yeah, I think there's something wrong right now with. I need to restart the engine maybe. I'm not sure why I'm not getting a preview, like a debug instance, which definitely should not be the case. I should be able to see what I'm doing here. Let's just take a look at player one worm. Yeah, my debug is broken. I literally did not see anything of value here. Yeah. I mean, this happens, but do my jumps count? Oh yeah, okay, this works. Alright, this works. So that's not an issue. Then why am I not getting the result needed? It's just a preview instance. I don't want the preview. That is not nice at all. It's feeding in my entry. I'm not even getting the idle. That's an issue. I'm actually in the middle of a jump. Oh, I see. Oh, okay. Then it is working. My bad, guys. Sorry. I'm in the middle of a jump, probably for some reason. And my lands don't actually operate, so there must be something that I've missed. And again, I will actually go ahead and take a look at this later down the line. I'm actually stuck in the jump. Check these guys out. I believe I'm stuck in the jump because my is grounded by default is false, and that's why we go automatically in the jump. So what if I make this to true? Okay, compile. It should be grounded. So if I play this, yeah, we don't get an update. That is quite weird. I need to take a deeper look at this. I'm not going to waste your guys' time because, again, it's just a redundancy where I just have to find out where I screwed up when I missed something, and it's basically done by checking out basically everything you've done, see where the issue could be. That's how debugging works. There's definitely a lot more. Like, you could use some other debugging tools in the developer tools, which is just like loads of them. Right? You can just click here, and you got loads of different stuff for textures, etc. But when it comes to code, in Blueprints, just to use your debug filter here. Okay, guys, I'm sorry this didn't work out the way I thought it would. I guess it comes with the actual fact that I did this on the fly. Maybe I missed something. Maybe I made a mistake somewhere with the logic. But as far as I'm aware, I'm actually not updating this live. Oh yeah, of course I'm not updating this live. Jesus Christ, sorry guys. Okay, this should have been actually not here. It should be in the update. Right, okay, like this. Like this, like so, and get the reference. Yeah, this should work now. Like so. And just, there we go, like this. Compile and play. Okay, we're still screwed. Still screwed. I don't know why this is a problem now. I'm not sure, guys. I really can't tell you because my is grounded is. I can see when screwed. Let me just see. Okay, now I'm stuck in jump. Now that doesn't even make sense at this point. So we have to see what's going on and why this actually is working like the way it is. Yeah, I'm surprised this isn't working. Whoa, whoa, whoa. Yeah, maybe we need to see what the story is. Okay, I'll see you guys next time when I have this sorted out. Even though I'm updating this per, per tick, maybe I'm doing something wrong here. I have to check. Okay, all right. I'll see you guys next time. I hope I kind of like you should know the basics by now, how animations and state machines and pretty much everything else works here. So. That's the rundown, the 101, the crash course. There's definitely other more in-depth tutorials on YouTube and around the internet. So make sure to do that and just check around some of the other tutorials because there's loads of different things that I did not touch upon, such as montages, curves, additive layers, morph targets, all sorts of stuff that you might need. And if you do, then obviously go ahead and check it out. Other than that, I'll see you guys next time when I've sorted this mess out, because there's definitely something that is not correct right now. All right? Okay, I'll see you guys next time. Bye-bye.